So given that in a group A consisting 7 boys and 3 girls, while group B consisting 6 boys and 5 girls, the number of ways 4 boys and 4 girls to be selected for a picnic if 5 of them must be from group A. So we have to select 5 from the group A and remaining 3 from the group B. So let us find the different possibilities. If let us say 3 girls are selected here, so the remaining girls can be, because total 4 boys and 4 girls, so 1 girl should be from here. So 4 girls satisfied, and again now for 5, 2 boys should be selected here, so that 2 boys must be here, so that 4 boys and 4 girls are completed. This is one possibility. And another possibility, if suppose 2 girls are selected, then there should be 2 girls from here, and boys, here 3 boys must be selected to get 5 count, and here 1 boy should be selected to get the count of 4 boys total. And next possibility, if suppose only 1 girl is selected here, then remaining 4 boys must be here, and if all the 4 boys are selected here, so then here 0 boys and girls can be selected 3. That's only these are the possibilities we are getting, so that we can write the combinations as so out of 7 boys, 2 boys are selected, that is 7C2. Out of 3 girls selected 3, that is 3C3. And out of 6 boys you selected 2 boys, 6C2. And out of 5 girls, 1 girl is selected, that is 5C1. And second case, out of 7, 3 are selected, that is 7C3. Out of 3, 2 are selected, 3C2. And out of 6, 1 is selected, 6C1. And out of 5, 2 are selected, so 5C2. And the third case, out of 7, 4 are selected, 7C4. Out of 3, 1 is selected, that is 3C1. Out of 6, 0 selected, 6C0. Out of 5, 3 are selected, that is 5C3. So these are the different possibilities of getting it. Let's simplify it separately. So say this is case A, say this is B, and say this is C. Case A, 7C2 into 3C3 into 6C2 into 5C1. And we know that NCR is equal to n factorial by r factorial into n minus r factorial, and NC0 is equal to NCN is equal to 1, NC1 is equal to NCN minus 1 is equal to n. So let us simplify, which is equal to 7C2, that is 7 factorial divided by 7 minus 2 factorial into 2 factorial. 3C3 value is 1 and 6C2 value is 6 factorial divided by 4 factorial into 2 factorial into 5C1 value is 5. So in here we can write 7 into 6 into 5 factorial divided by 5 factorial into 2 factorial. And here 6 factorial we can write 6 into 5 into 4 factorial divided by 4 factorial into 2 factorial is 2 into 5. So on simplifying we get, so here we can cancel 5 factorial, here 4 factorial, and here 2 3 times, and here 2 3 times. So 7 3s are 21 into 315 into 5. So 21 into 15 into 5, we can say 1575. Now let's consider the second case. Second case we can write 7c3 into 3c2 into 6c1 into 5c2. So we can write 7c3 value. So denominator will be 4 factorial. So let me write 7 into 6 into 5 into 4 factorial divided by 4 factorial into 3 factorial is 6. And 3c2 value we can write 3 factorial, that is 3 into 2 into 1 divided by 3 minus 2 is 1 and 2 factorial 2 into 1. And 6c1 is nothing but 6 and 5c2 value is 5 into 4 into 3 factorial divided by 3 factorial into 2. So on simplifying, we get 4 factorial, 6 gets cancelled, and here 2 and 3 factorial, and here 2 times. So we'll be getting 7 5s are 35 into 3 into 6 into 10. So which is 18 tens are 180, 180 into 35. 6300. And case C, so we have 7c4 into 3c1 into 6c0 into 5c3. So here we can write 7c4 is 7 into 6 into 5 into 4 factorial divided by 4 factorial into 3 factorial, that is 3 into 2, and 3c1 is 3 and 6c0 is 1. 5c3 value we can write 5 into 4 into 3 factorial divided by 3 factorial into 2. So we can cancel 4 factorial here and 3 into 2 6 and here 3 factorial and 2 times. So on simplifying we get 7 5s are 35 into 3 into 10. So 30 into 35. So which is 1050. So from all the cases the total possibilities total number of ways is equal to 1575 plus 6300 plus 1050. So we'll be getting 8925. So 8925, which is our option B. Given 7 is equal to sum of the series 5 plus 1 upon 7 of 5 plus alpha plus 1 upon 7 square of 5 plus 2 alpha plus 1 upon 7 cube of 5 plus 3 alpha and so on up to infinity. So here we can observe that 5, 5 plus alpha, 5 plus 2 alpha, 5 plus 3 alpha. It's an arithmetic progression with a common difference is alpha and first term is 5. And also we can also see that there is a 1, 1 upon 7, 1 upon 7 square, 1 upon 7 cube. It's a geometric progression with a common ratio is equal to 1 upon 7. So simply we can say that this is an arithmetical geometric progression, the right hand side. So to solve this type of problems, we need to multiply with the common ratio r. So let us multiply r 1 by 7 on both the sides. So we can get 7 into 1 upon 7 is equal to, so here I can write 5 by 7 plus 1 upon 7 square of 5 plus alpha plus 1 upon 7 power 3 of 5 plus 2 alpha plus 1 upon 7 power 4 of 5 plus 3 alpha and so on up to infinity. That is 1 is equal to, we can start from here, 5 by 7 plus 1 upon 7 square of 5 plus alpha plus 1 upon 7 power 3 of 5 plus 2 alpha and so on up to infinity. Let us subtract from the equation 1, say this is 1. So we can write 7 is equal to 5 plus 1 upon 7 of 5 plus alpha. So we can write 1 upon 7 of 5 plus alpha plus 1 upon 7 square of 5 plus 2 alpha, 1 upon 7 power 3 of 5 plus 3 alpha, and so on up to infinity. Say this equation is 2 and this is an equation 1. So let us subtract equation 1 minus equation 2. So we get 7 minus 1. 7 minus 1 is 6 is equal to 5 minus 0 is 5 plus, and here 1 upon 7 of 5, that is 5 by 7 and 5 by 7 get cancelled. So I can write here 1 upon 7 times of 5 plus alpha minus 5 by 7, that is 5 by 7 plus alpha by 7 minus 5 by 7. So we can get alpha by 7 here. And similarly 1 upon 7 square, 1 upon 7 square of 5 plus 2 alpha minus 1 upon 7 square of 5 plus alpha. 1 upon 7 square I can take common. So 5 plus 2 alpha minus 5 minus alpha. So we get alpha by 7 square. So the second term will get alpha by 7 square. And similarly the next term will get alpha by 7 power 3 and so on up to infinity. So we can write 6 minus 5. 1 is equal to alpha by 7 plus alpha by 7 square plus alpha by 7 power 3 and so on to infinity. So the right hand side we can see this is an infinite GP. Infinite GP. So with first term, or you can take alpha by 7 common also. Our first term a is equal to alpha by 7 and r is equal to 1 upon 7. And sum to infinity in GP is a divided by 1 minus r. So here we can write 1 is equal to alpha by 7 divided by 1 minus 1 upon 7, which is equal to alpha by 7 divided by 7 minus 1, 6 upon 7. So 1 is equal to alpha upon 6. So which implies alpha is equal to 6. Therefore we can say the value of alpha is 6. Option 3. Given that a and b are the coefficients of 30th and 12th terms respectively in the binomial expansion of 1 plus x whole power 2n minus 1. So basically we know that in the expansion of 1 plus x whole power n, general term tr plus 1 is equal to ncr x to the power of r. Here we required about the coefficient, that is ncr. So for 30th term we can write t29 plus 1, which is equal to 2n minus 1 c 29 into x to the power of 29, and 12th term we can add t 11 plus 1, which is equal to 2n minus 1 c 11 x to the power of 11, and the coefficients are given, that is 2n minus 1 c 29 and 2n minus 1 c 11, which are given as a and b. So we can say this is a and this is b. And also the relation 2 times a is equal to 5 times b, that is 2 times 2n minus 1 c 29 is equal to 5 times 2n minus 1 c 11. Let us use the property ncr is equal to n upon r n minus 1 c r minus 1. So which also implies n minus 1 c r minus 1 is equal to r upon 10 times r upon n times of ncr. So here I can write 2 times 2n minus 1 c 29. So I want to apply this formula here. So I can write r upon n, that is 29, we can write it as 30 minus 1. So 30 divided by, and here n is nothing but 2n when comparing, into ncr, that is 2n c 30, which is equal to, similarly here also I can write 5 times 2n minus 1 c is 12 minus 1, I can write. So r is equal to 12 here. So I can write r by n, that is 12 divided by 2n into 2n c 12. So I can cancel 2n on both the sides, and also 5 6 times 6 2s are 12 gets cancelled. So we got 2n c 30 is equal to 2n c 12. We had the property if ncr is equal to ncs, either r is equal to s, or we can say n is equal to r plus s. So here 30 cannot be equal to 12. So we can conclude now 2n is equal to 30 plus 12. That is 2n is equal to 42. So n is equal to 42 upon 2, which is 21. So we can say the value of n is equal to 21, which is option B. Given three lines, x plus y is equal to 11 and x plus 2y is equal to 16 and 2x plus 3y is equal to 29. So they can be drawn here on the xy plane, and you can see that the triangle formed by these lines is here. So this is a triangle formed, and we need to identify the point 11 by 2 comma alpha maybe lies on or inside the triangle. Then we need to find the largest and smallest values of alpha product. So let us find the point of intersection of these two lines here, this point. So that is x plus 2y is equal to 6. Solving, x plus 2y is equal to 16 and x plus y is equal to 11. Subtracting both, we got y is equal to 5, so that x is equal to 6. So we got 6 comma 5 is the point, and 11 by 2 is the line which is just before this 6, that is 5.5. So let us draw the line. So this is the line, x is equal to 11 by 2. So which will intersect this triangle at 2 points. So put x is equal to x by 2 in the line equation. X plus y is equal to 11. So we get y is equal to 11 minus 11 by 2, that is 11 by 2. So we can say this point, say A point is 11 by 2 comma 11 by 2. And also let us substitute the x is equal to 11 by 2 in the another line, 2x plus 3y is equal to 29. Put x is equal to 11 by 2 in the line equation, 2x plus 3y is equal to 29. So 2a times x is nothing but 11. 11 plus 3y is equal to 29. So we got 3y is equal to 29 minus 11, that is 18. So y is equal to 6. Say this point is B. So B is the point 11 by 2 comma 6. So we can say since it is lying on or inside the triangle 11 by 2 comma alpha, so we can consider the smallest value is 11 by 2 because 11 by 2 comma alpha. So the smallest value of alpha is 11 by 2. And the largest value is maximum is 6. Largest value of alpha, which is equal to 6. Hence the product. Therefore, the product is nothing but 11 by 2 into 6, that is 33. So 33, which is our option D. So 33 is the answer. So given an ellipse equation, x square by 25 plus y square divided by 16 is equal to 1. And we need to find the equation of the chord whose midpoint is given 3 comma 1. So we know the formula when the midpoint of a chord is given, t is equal to s1. So t is nothing but xx1 divided by a square plus yy1 divided by b square minus 1 is t, and s1 is nothing but x1 square divided by a square plus y1 square divided by b square minus 1. So here the point is given 3 comma 1. So we can write equation of chord t is equal to s1 so we can write t value, that is x into 3 divided by 25 plus y into 1 divided by 16 minus 1 is equal to 3 square by 25 plus 1 square by 16 minus 1. So here minus 1 gets cancelled. So here we can get 3x by 25 plus y by 16 is equal to 9 by 25 plus 1 by 16. So here take in LCM, 25 into 16. So here 3x into 16, that is 48 times x plus 25 times y is equal to 16 into 9, 144 plus 25 divided by 25 into 16. So the denominator 25 into 16 gets cancelled on both the sides. And here we can write 48x plus 25 is equal to 169. So which is our option B. So second option, 48x plus 25y is equal to 169. Given in an arithmetic progression, S40 is equal to 1030. We know that sum to n terms in arithmetic progression whose first term is a and common difference is d is given by Sn is equal to n by 2 of 2a plus n minus 1 into d. So here we can get S40. S40 is equal to 1030. So which implies 40 by 2, 2a plus 40 minus 1, 39 times d, which is equal to 1030. Or here we can get 2a plus 39d, which is equal to 1030 divided by 20. So we can write 2a plus 39d is equal to 103 divided by 2. Make this an equation 1. And also given S12 is equal to 57. So we can write S12 is equal to 57, which implies 12 by 2, 2a plus 11d, which is equal to 57. So here 6 times, or 2a plus 11d is equal to 57 divided by 6. Make this an equation 2. Now solving, subtracting 1 and 2. So equation 1 minus equation 2, we get 39d minus 11d is equal to 103 upon 2 minus 57 upon 6. So that is 28 times d is equal to, so here 3 times, so 309 minus 57 divided by 6. That is 28d is equal to, so 309 minus 57 will get 252 divided by 6. So which implies d is equal to 250 divided by 6 into 28. So here 6 how many times? 642 times 252, and again 42 7 14 table, 14 threes are 14 twos are. So we got the common difference d is equal to 3 by 2. Now substituting d is equal to 3 by 2 here, 2a plus 11 into 3 by 2, which is equal to 57 divided by 6. That is 2a is equal to 57 by 6 minus 33 divided by 2. 2a is equal to 57 minus here 99 divided by 6. So here we can write 57 minus 99 minus 57 is 42. So 2a is equal to minus 42 divided by 6, or here 6 7 times. So the value of a is equal to negative 7 upon 2. So first term a is equal to minus 7 by 2 and d is equal to 3 by 2. Now we need to find S30 minus S10. S30 minus S10, which is equal to 30 by 2 times of 2a plus 29d minus 10 by 2 times of 2a plus 9d. So I can take 5 common, so that 3 times 2a, that is 6a, and 3 times 29, 60 plus 27, 87d minus, and here 2a minus 9d, which is equal to 5 times 6a minus 2a is 4 times a, and 87 minus 9. So we can write here 78, 78d plus 78d. So substituting a is equal to minus 7 by 2. So we can write 5 times 4 into minus 7 by 2 plus 78 times 3 by 2, which is equal to 5 times. So here it comes minus 14, and here it is 39 3 times 117, which is equal to 5 times 117 minus 114, 14 is just 103. So 103 5 times, we'll get 515. So the answer is 515, which is option 4. Let us consider from the set A, log of
to the base 2 upon pi mod sin x plus log of to the base 2 upon pi mod cos x is equal to 2, where x belongs to 0 to pi, excluding pi by 2. So we know the property log a plus log b to the same base, we can write log ab. So here we can write log 2 upon pi is the base, mod of sin x into mod of cos x, that is mod of sin x into cos x, which is equal to 2. This can also, we have the property log a to the base x is equal to m. We can convert into exponential form as a is equal to x to the power of m. So here we can write sin x cos x is equal to 2 by pi whole to the power of 2. Here multiply and divide with 2 here, 1 upon 2 times of 2 sin x cos x, which is equal to 4 upon pi square. 2 sin x cos x is sin 2x. Sin 2x is equal to 8 upon pi square. So 8 upon pi square value is less than 1. And if you see the graph of sin 2x, this is a graph of sin 2x, and since it is a mod sin 2x, it will be in the positive first quadrant. This one, and 8 upon pi square value, 8 upon pi square value can be taken as a line. This is 8 upon pi square, and this is sin 2x. So we can say clearly that mod of sin 2x is equal to 8 upon pi square, which is forming it to 4 points. 1, 2, 3, 4. So graphically, we can say the number of elements in set A is equal to 4. Is a 4 points where the line intersect the sin 2x mod sin 2x graph. Now let's consider set B. So we have the equation root x of root x minus 4 minus 3 mod of root x minus 2 plus 6 is equal to 0. So for our convenience, let root x is equal to p. So we can write p times of p minus 4 minus 3 times of root x, that is p minus 2 plus 6 is equal to 0, and where x is positive. So p is positive. So we can write p square minus 4p, and let us also assume that p minus 2 is greater than 0 in one case, case 1, so that we can write minus 3 times of p minus 2 plus 6 is equal to 0. So we can write p square minus 4p minus 3p, and again plus 6, that is plus 12 is equal to 0. So we can take p common, so p minus 4 minus 3 common, p minus 4 is equal to 0. So p minus 4 into p minus 3 is equal to 0. So we can say p is equal to 4 and p is equal to 3. So p is root x. So root x is equal to 4, and here root x is equal to 3. So we can say x is equal to squaring on both sides, so 16, and here x is equal to 9. So the 4 and 3 both are greater than, since p is greater than or equals to 2, so both are greater than 2. So we can consider the first case. And coming to the second case, case 2, when p minus 2 is less than 0. So here we can write p square minus 4p. So when p minus 2 is less than 0, so we'll get mod of p minus 2 negative. So minus of minus plus 3 times of p minus 2 plus 6 is equal to 0. So we can simplify p square minus 4p plus 3p, and again here minus 6 plus 6 is 0. So p square minus p is equal to 0. So we can take p of p minus 1 is equal to 0. So either p is equal to 0 or p minus 1 is equal to 0. And it is given p is less than 2. So both the values p is equal to 0 and p is equal to 1, both the values are less than 2. So we can conclude, we can consider this. So root x is equal to, or root x is equal to 1. So here x is equal to 0, squaring on both sides, so x is equal to 1. Since x is positive, so we consider the positive values. So we got the set number of elements in set B is equal to 4 elements are there, 16, 9, 0 and 1. And also we can see that these values will not match to the set A. A and B are disjoint. When they are disjoint sets, we can say number of elements in A union B is equal to n of A plus n of B. So we know n of A is equal to 4 elements. So n of A is 4, n of B is 4. So 4 plus 4, 8. So 8 is the answer, which is our option 1. So the equation of the parabola with the vertex 3 by 2, comma 3 and the directrix x plus 2y is equal to 0 is given in terms of alpha, beta, gamma. So actually to find the equation of the parabola, we need to find axis of parabola equation so that we can find the focus also. So to get the axis of parabola, let us take the slope of directrix. Slope of x plus 2y is equal to 0, which is taken as minus 1 by 2. So which implies slope of axis of parabola, which is equal to 2, since axis and the directrix both are perpendicular. And it is passing through the point vertex. So equation of axis y minus y1 is equal to 2 times of x minus 3 by 2. So that is y minus 3 is equal to 2 upon 2 times of 2x minus 3, or y minus 3 is equal to 2x minus 3. So 2x is equal to y, or we can say 2x minus y is equal to 0. So this is an axis of parabola, 2x minus y is equal to 0. So the point of intersection of these both, clearly we can see it is origin, 0 comma 0. So this is O. And let the focus is the point S, say alpha comma beta. Since vertex is the midpoint of origin and this focus, so we can write 3 by 2 is equal to alpha plus 0 divided by 2, and 3 is equal to beta plus 0 divided by 2. That is alpha is equal to 3 and beta is equal to 6. So we can say the point alpha comma beta is 3 comma 6. This is a focus. Now let us consider any point on the parabola. Let P x comma y be any point on parabola. Say the point is here, P x comma y, so that according to the concept, SP is equal to, so we have the concept SP is equal to such that SP is equal to PM. Since we know that SP is equal to E times of PM, where E is eccentricity, for parabola eccentricity is 1. So the distance between the focus to the point is equal to the distance between the perpendicular distance between point upon the fixed line. So this is a fixed line directrix and it is a fixed point focus. So there is a relation between both. So SP is equal to under root of x minus 3 whole square plus y minus 6 whole square. So SP square is equal to x minus 3 whole square, that is x square, plus 9 minus 6x plus y square plus 36 minus 12y. And similarly, the perpendicular distance from point upon the line PM is equal to x plus 2y upon a root of 1 square plus 2 square, that is x plus 2y mod upon root 5. Now PM square is equal to x square plus 4y square plus 4xy divided by 5. Now let's equate it. Since SP is equal to PM, so we can write SP square is equal to PM square. X square minus 6x plus y square minus 12y plus 36 plus 9, 45 is equal to x square plus 4y square plus 4xy upon 5. The cross multiplication 5x square plus 5y square minus 30x minus 60y, and here 45 5 times 225, which is equal to x square plus 4y square plus 4xy. So bringing to one side, 5x square minus x square is 4x square, and 5y square minus 4y square is plus y square, and here minus 30x and minus 60y, and this is minus 4xy plus 225 is equal to 0. So when comparing this equation, alpha is 4. When comparing with the given equation, alpha is equal to 4, beta is equal to 1, and gamma is equal to 4. So alpha here, 1 beta here, and gamma. So that we need to find alpha plus beta plus gamma, which is equal to 4 plus 1 plus 4, which is equal to 9. So 9 is the answer, which is our option 3. We need to find the number of real solutions of the equation x square plus 3x plus 2 is equal to minimum of mod of x minus 3 and x plus 2. And here the vertex of the parallel, let us consider the left hand side, x square plus 3x plus 2, say this is y. The vertex of the parabola is minus b by 2a comma minus delta by 4a. So here a is equal to 1, b is equal to 3, and c is equal to 2, and delta is equal to b square minus 4ac, that is 9 minus 8, which is equal to 1. So I can write minus 3 by 2 comma minus 1 divided by 4. minus 3 by 2 comma minus 1 by 4. So we can consider the word is here. And since the coefficient of x square is positive, so the curve will be open upwards. And let us consider x square plus 3x plus 2, which is equal to negative of x plus 2. That is x square plus 3x minus plus x and plus 4 is equal to 0. That is x square plus 4x plus 4 is as x plus 2 whole square. That is x is equal to minus 2. We set x is equal to minus 2, we are getting the point. So we can see the graph can be taken. And similarly, when we consider x square plus 3x plus 2 is equal to positive of x plus 2, because in both the cases we can say this is the minimum till here. That is solving x minus 3, negative of x minus 3 is equal to x plus 2. So we get 2x is equal to 1. So x is equal to half. So we're getting this point as x is equal to 1 by 2. Till x is equal to 1 by 2, we are getting the minimum is nothing but mod of x plus 2. So we can take x plus 2. So x square minus 2x is equal to 0. That is x of x minus 2 is equal to 0. So x is equal to 0 and x is equal to 2. At x is equal to 0, you are getting y is equal to 2. Means you can say the graph will intersect the point here. So the parabola can be taken as this is the parabola we can consider, and clearly we can say that the graph is intersecting in the minimum portions. There are only 2 points. So those are, one point is here, that is minus 2 comma 0, and another point is here, that is 0 comma 2. So remaining you can intersect, it is intersecting, but it is a greater. It's not minimum of x minus 3 and x plus 2 mod. So we can conclude that there are only 2 points. So there are 2 solutions which satisfies the condition, option B. Given hyperbolas h1 x square upon a square minus y square upon b square is equal to 1, and hyperbola 2 minus x square upon capital A square plus y square upon capital B square is equal to 1. Having length of lattice rectum, so here lattice rectum we can say 2b square upon a, which is given as 15 root 2, and here we can write 2 capital A square by b is equal to 12 root 5, and their eccentricities E1 is equal to under root of 5 by 2, so which is under root of 1 plus b square by a square, and here we need to find the eccentricity E2. And if the product of length of the transverse axis, so here transverse axis length can be taken as 2a, and here the length of transverse axis is equal to 2b, so that their product 2a into 2b which is equal to 100 root 10. So from eccentricity E1, we can write 1 plus b square by a square is equal to 5 by 2, or b square by a square is equal to 5 by 2 minus 1, that is 3 by 2. So b square is equal to 3 by 2 a square. And here 2b square upon a is equal to 15 root 2. Say this is 1 and this is 2. So from 1 and 2, we can write 2 upon a into 3 by 2 a square is equal to 15 root 2. So here a is equal to 15 root 2 divided by 3, which is equal to 5 times root 2. So substituting a is equal to 5 root 2, here 2 into 5 root 2 into 2b is equal to 100 times root 10. So which we can write 2 5s are 10, 10 times, and again 10 2s are 20, 25 times. So b is equal to root 10, we can write root 2 into root 5 divided by root 2, and again 5, root 5. So b value is 5 root 5. Now consider E2 eccentricity for the second hyperbola, which is equal to under root of 1 plus a square by b square, which is equal to under root of 1 plus, and from the equation 2a square by b, we can write 2a square is equal to 12 root 5 into b value, that is 5 root 5. So a square is equal to 6 5s are 30, 30 into 5, which is equal to 150. So we can write a square value is 150 divided by b square value is 5 root 5 whole square, that is 25 5s are 125, which is equal to under root of 1 plus. So here we can write 25 6 times and 25 5 times, which is equal to under root of 11 by 5. So eccentricity E2 is equal to under root of 11 by 5. Then E2 square is equal to 11 by 5, and 25 times E2 square is equal to 25 into 11 by 5, which is equal to 55. So the answer is 55. Okay, it's a numerical. Number of functions f from 1, 2, 3, and so on up to 98, 99, and 100. So total 100 numbers are there in the domain. So map it to 0 and 1 with only 2 elements, and it is given that assign 1 to exactly one of the positive integers less than or equals to 98. Means this 1 can be assigned to either to 1 or to 2 or to 3 or to 98. So we can say 1 can be assigned to 1, 2 can be assigned to 1, 3 can be assigned to 1, and so on. 98 can be assigned to 1. Means this 1 can be assigned to 98 numbers. So 98 ways are there.
Similarly, the next remaining two numbers 99 can be assigned to 99 can be assigned to 0 or 99 can be assigned to 1. So there is no condition. Similarly, 100 also can be assigned to 0 or 100 can be assigned to 1. So here total 4 ways are there. So therefore the total number of functions defined from 1 to 100 to 0 to 1 with the given condition, we can write 98 into 4, that is 392. So 392 is the answer. It's a numerical type question.